Okay. So very first thing which we need to understand, it's graphs of different shapes. Yeah. So different equations have different meanings or different types of graphs. So when we distribute or we divide the shapes and their graphs, we have a three major category. Yeah? X with the power of even, maximum of the even number. Actually, they all are the polynomials, and these polynomials do have different types. So we can have X with the even powers, X with the odd powers, and either we can have reciprocal graphs, or either we can have relate to the reciprocal of the other kind of the graphs. Yeah, you can say exponential also includes. So if we categorize them, so we have a four major kind of things which we really need to understand. Yeah. So first few things which we're going to understand, it's going to be x with the power of even. Yeah. So let's think about it. When we say x to the power even, it means we are talking about x to the power 2, x to the power 4, x to the power 6, and so on. Yeah. X to the power anything, which is going to be something. Yeah. Then when we distribute our graphs, we distribute x to the power odd thing. Yeah. So it could be 1, 3, 5, and so on. And then x to the power, let's say 99 or something. Yeah. So
Mhm.
this x to the power 1, when we take, it's more over a straight line. Yeah. Now the secret which we need to talk about. So let's write down more things. So the secret is the ends of the graphs. Yeah. So ends of the graph. If you know about the ends, and then if we know about the turns. Yeah. So these are the two things. Yeah. Which is very important for us. Yeah. So let's keep
Yes,
that.
sir.
Initially, we have ends and the turns. Yeah. So ends depend on the power. If the power is even or the odd. Yeah. So on the base of the power, we decide the ends. So if the power is even, then ends are on the same direction. On the same direction. Yeah. The graph's ends will be on the same direction. So we get to the examples. Okay, let's go a little examples below. Yeah. So when we have an even, so graph ends can be both upside or then here we can have a different kind of we can have one turn, either we can have two turns, or either we can have multiple turns. Yeah. So turns can be anything. That's we split turns and ends. Yeah. So end will be always either upward to the same direction,
Downward.
or
Yeah.
either it could be downward to the same directions. And then similarly we can have either a one turn, or either we can have multiple turns. That turns based on the power. Yeah. So turns we decide from the power. So let's write down the formula for the turn. Yeah. So let's make a turn formula. So when we want to find it out, the turn formula, so turn we find it out, power minus 1. So it means whenever we're going to look, so on any of the equation, we should have a sketch behind our mind straight away, that how it's going to be look like. Yeah. So now
Yes,
we
sir.
just had, if we know that the power will be positive. Yeah. So all these even powers which we look here. Yeah. They're always going to be either above or either below. Yeah. So now it's all depends on their turn. So let's make a little chart about the turns. Yeah. So which has how many turns, turns, let's say. So 2 minus 1, that make 1 turn. 4 minus 1, that makes 3 turns. 6 minus 1, that makes 5 turns. So 100
Five.
minus 1 will make 99 turns.
99.
So we just know very much of the clear thing. So let's just roughly sketch the thing. Yeah. X square, both will be upward and one turn. So this is my X square graph. Yeah. If I look for the X4 graph, the ends will be up, and how many I should have 3 turns. So this is my X4 graph. Yeah. How quick and fast this one. Yeah. So if I X to the power
Mhm.
6, my turns are there, and I should have 5 turns. 1, 2, 3, 4, and 5. So this is X to the power 6. Yeah. 99 definitely we're not going to draw it. Yeah. Now the
Yeah.
question which should comes in our mind. Yeah. Question which should comes. So what happened? When we take graph upward and when we take the graph ends downward. Yeah. So that is very much depend on the coefficient of the x to the power of the thing. Yeah. So this coefficient. So coefficient is a very important thing. Yeah. If the coefficient is greater than zero, then the ends are always going to be upward. Okay. And if the coefficient is if the coefficient is uh, a less than zero, then the turns should be always downward. Yeah. So it depends, whatever, but the ends will be downward. Yeah. Ends will be downward. And okay, let's remove this one so it doesn't make the confusion. Yeah. We know that. Then after the downward or upward, if we know the turn, we know the direction or the sides ends direction, then afterward we just draw these kind of thing. Okay, let's take a couple of example and that makes very much clear to us. Yeah. If I have a
Mhm.
plus x square, then I know that it's a x square, then my turns will be up. And so my directions will be up and my turn will be only one. Yeah. That makes x square graph. Yeah. So usually we have a symmetrical graph. So then that should be like this. Yeah. Okay, and if we have minus x square, so we know that the ends will be on the downward and we will have a one turn. And due to negative, it will have downward. And definitely due to the power, it has only one turn and one turn. Yeah. And then there is another thing called turning points nature. Turning points nature. Yeah. We get to that later on, but this is also a very important thing. We do have a turning points nature. When we are sketching any kind of graph, we look and think about the turning points nature, and also we should know the x intercepts and y intercepts. Yeah, these are the two separate things. Definitely we know that if we have the turning points, how to get to the nature. If you don't know, you
Mhm.
just recall back again. But to finding a x-intercept, we know that we need to put y equals to 0 into the equation. And when we need y-intercept, we put x is equals to 0 into the equation and get those intercepts. Yeah. So right here, we are more concerned when we are drawing a graph, how the graph should be look like. So for the very first one, we talked about the even power. We said that even power always have the turns either upward or either downward, and sorry, directions of the ends always upward or downward. And the power, due to the power, we decide the number of turns. That's how we need to go off. Yeah. So let's take one example of x to the power 4. Yeah. So let's say we have plus x to the power 4 and minus x to the power 4. Yeah. Plus x to the power 4 graph. So it means ends will be upward. Yeah. And my turns will be 3. 1, 2, 3. So that's how x to the power 4 plus sign. If you have a positive coefficient and x to the power 4, then we're going to draw the graph in this direction. Yeah. If you have minus x to the power 4, we have a downward ends and we have a 3 turns. Yeah. So this is going to be x to the power 4 graph. Yeah. Okay. So the turning
Oh,
point which I was talking about, so definitely as many turns we have, as many turning points we have. Yeah. And definitely if we talk about the nature, then the ones are below that makes minimum points, above are the making a maximum point. Yeah. So there is another thing which is called local maxima, local minima. Yeah. So that is also one of the concept which we will talk about later. Local maxima and local minima. Yeah. Okay. So, but definitely we
yeah.
know that this is the minimum point, this is the maximum point, and we also can decide this is a maximum point and these are the minimum points, and these are the two maximum points and one of the minimum point. Yeah. But that's depend. So the thing which I want you to understand, it's that whenever we have an equation of the graph or any polynomial equation, how we can look on the graph and then decide very quickly of the things. Yeah. Let's just reconsider things what we have learned. That very first we look that the power is odd or even, and
Yeah.
definitely we just learned about the even powers, that if it's a even powers, we know that the directions of the ends will be either upward either downward, but
or
they're
downward.
always going to be in the same direction. Yeah, they're always
Yeah.
going to be in the same direction if the power of maximum power of the equation is the even number. Okay. Then we talked
Mm-hmm.
or saw two of the examples, and we decided that the how many turns graph will have, we just decide through the power. Yeah. So we make power minus one as many turns we have it. Yeah. Now let's think about it back again about our odd powers. Yeah. So what will happen with the odd powers? So if we have odd powers, then the ends will be on the different directions. Yeah. They will be on a different direction. So those will be on different direction. Different direction is moreover like opposite, uh, or you can say diagonal opposite, diagonal opposite quarters. Yeah. Okay, we talk about what we mean about the quarters. So if we look in a journally, we have our coordinates x and y or a plane, and this one is first quadrant, the second quadrant, third quadrant, and the fourth quadrant. Yeah. So if we
Mm.
have a
Yeah.
yeah, quadrant one and three, so they're going to be the diagonal opposite, and two and four will be the other diagonal opposite. Yeah. So if we have like x cube, even though if we have x to the power 1, yeah, so we generally have end here and here. Yeah, we have end here and here. Yeah, so this is going to be opposite ends,
Yeah.
but they're going to be diagonal one. Yeah. Now when
Oh.
we have x to the power 1, 1 minus 1 is 0, so it means there should be no turn. There should be no turn, and this will
Yeah.
become like a straight line, and ends remains in first and third. Yeah. Okay. But when it happened,
Oh.
how it happened, it very much depend on the coefficient of A. Again, if my coefficient of A is greater than 0, which means positive, then it means my ends will be in the first and the third quadrant. Yeah, first and third quadrant. If my coefficient is less than 0, which is means negative, then my ends will be in and second and fourth quadrant. Okay, so that's why when we have a positive gradient, we draw like this graph. When we have a negative gradient, we draw like this graph. Yeah. So similarly,
Yes,
now
sir.
if we look at for the x cube, then we know that my graph will be for the A positive, it's going to be on this, and 3 minus 1 give us the turn, which is 2 turns. So it means 1 turn and second turn. Yeah. So
Mm-hmm.
that makes my x cube graph is positive. Yeah. If his x cube graph is negative, then it makes definitely this end to this end, and 3 minus 1 gives 2 turns. Then it means it's 2 turns. We just
Yeah.
more clear. Let it remove this one. So this seems more accurately drawn. Yeah. So this is negative x cube graph. This is positive x cube graph. I think this makes a very good sense when we look into the turns and ends. Yeah. So this makes the life very easy to at least
Mm-hmm.
identify the graphs in a direction which we are looking for. Yeah. Right. Okay, next when
Yeah.
we have x to the power 5 and we make positive x to the power 5, then definitely we know that and my ends will be from the first to end, this one. Yeah. Now the next
Yeah.
thing which we need to look is 5 minus 1, which makes 4. My 4 terms, it means I have 1, 2, 3, and 4. Yeah. So this is going to be my 4 turn, and that's graph going to be look like very much of positive x to the power 5. Stretching could be anything, so we should not worry about it. If the graph looks like this, I still have 1, 2, 3, 4 turns. I have two opposite turns, then it means it's positive of x to the power 5 graph. Yeah. Then stretching and more adding things can happen, which makes the graph shapes up, down, slanting, tilt, higher, lower. Yeah.
Yeah.
But when we have minus x to the power 5, then it means graph should be like 1, starting from the 2, and then 1, 2, 3, 4, and 5. Yeah. So 1, 2, 3,
Mm-hmm.
4. and this one. So this is my negative because my it's starting from the second quadrant, goes to the fourth quadrant, and it means this is my one of the thing which we have. Yeah. So now this also makes one another graph, which is when I look for my odd graphs. Yeah. Afterwards,
Okay.
we can have our reciprocal graphs. Yeah. Now, reciprocal graphs have its own criticality, yeah, but we need to understand A is the critical thing. Coefficient of any of the graph is the critical thing, yeah. So let's say we have A times 1 over x, which makes my A over x, yeah. Now, 1 over x
Yeah.
do have understanding of asymptote, and that's where we look how my graph's going to be look like. So what is happening? Asymptotes are the lines which never going to be touched. They also always going to be pass on things. Yeah. So
Wait, what do you mean?
we have a two kind of thing which is really meant to be. So my horizontal asymptote and vertical asymptote. Yeah. So if my whole thing goes towards two, so if I take this my denominator equals to zero, because if if I have 1 over 0, yeah, what that mean to me? Infinity.
Yes, infinity. Yeah,
Yeah, it means
100%.
I never going to touch that of the thing. Yeah. So this is what one kind of a thing when I look at this is my x equals to 0 line. Yeah. This is my x equals to 0 line. Yeah. So it means if my
Yeah,
coefficient will become my denominator, sorry, becomes 0. Yeah. If my denominator will come 0, then my graphs will never going to be touched this one. So graphs coming from here or coming from here. So it could be coming from positive infinity or a negative infinity because 0 is the neutral, we don't know. Yeah. So, but it means my 0 will never be touched. Correct. So my graph can be come up from either positive side or either negative sides. It's never going to be touched. Now, then they will be
wait.
turned. Then they will be turned, and when it's turning it, so it means that I can find out my turn at when it's equals to 1, yeah, or I can put into any value. So I put x to the 1, so that makes 1 and 1, yeah, that makes 1 and 1 value. And if I put negative 1 value, then it makes minus 1 and minus 1 value, yeah. So these are the two terms, and then we need to look if I apply x value with the greater number, yeah, so what will happen? If I apply the greater value of the x, so like x should be greater than 0 or x should be less than of a 0, yeah. So more bigger value come up. So what happened? What do you think if I have very huge values of this, yeah? So this is going to be like 0.000001, but it never going to be 1. So never going to be 0, correct?
Yeah, it
So
still crosses the y-axis. Wait, no.
yes, so
Wait, one.
it never going to be cross the y-axis because my y results will never going to be a 0. My y going to be never to be a 0. So if anything, never going to be 0, and it's never touched those lines where these lines get narrows and pass on these kind of lines known to be asymptotes. Okay, so we have
Yeah,
1 over
y
x.
is, yeah.
Yeah, we have,
Y is basically infinity. Yeah.
yeah. Okay, so the thing is that's the it's never going to touch of that line, which is y is equals to 0, because it's always going to be a smaller value, but it never going to be 0. Yeah. Similarly, for the all the range of the values of on the number line from 0 towards to positive infinity. Yeah. If I add any of the value due to I have 1 over x, yeah, and my coefficient of a is also positive. So it means this is positive, and whatever the x value I will add up, they always been a positive value. Yeah? So my results are positive. So that's is the reason that my one of this graph is remain in this quadrant, because my all results for x and y, they're always going to be positive results. Yeah, they're always going to be positive results. Positive infinity, it will increase towards to positive infinity, and this direction increase to positive infinity. So this a impact is always going to change this direction only. So if I had, let's assume I have 2 over x, yeah. So if I have a 2 over x, then it's mean my 2 to 2 will become here, yeah, when I have 2 and when I have 2. So this point becomes, so it means my curve just extend like this and go towards to this one. So it means increasing the a value will just lift my this graph middle part, yeah. But the remaining part, like endings or ends, are always move towards to positive infinity of y-axis and towards to positive infinity of my x-axis, yeah. So this is going to be there. So let's make a little undo, so we just have a knowledge this one. And now what happened that if we have a negative x of the value, so like we are looking for the other side of the range of the x values, yeah, which is extending to negative values. So if I have my a is positive and if I keep ending up my x value negative, they will be negative number, and definitely they are going to be a tiny negative number like 0.00001, just similar like this. If I put like 1 over minus 1,000,001,000, still be a negative of 0.001. So it means it will keep extend towards to it, but it never going to touch to that my x negative x part of the x-axis, yeah. So it means this is also due to infinity of positive infinity and negative infinity, this extension will be there, yeah. So this is happening when we are saying my a is greater than 0. So my a is greater than 0. Now what will happen? This is going to be interesting look now, yeah. Let me take a little zoom out so we can still see this screen. And let's think and talk about in the same reciprocal graph, when my a is going to be less than 0, yeah. So now what I'm saying, my a is negative and I have a x here, yeah. So what happened? It's a negative sign. So if I entered anything positive value, my positive x values, yeah. So it should have the similar part of the thing, but it will give my, for the positive x value, it give my y result as a negative. So if I have this one and I put my positive results here, minus over plus, I still get minus. So it means my y results will be negative, yeah. So for all of these values, my y will be extending towards to negative infinity, yeah. So this is happening when we are saying we have minus 1 a over x. Now, what will happen? This is for the when I put my x as a positive range, yeah. When my x is greater than and equals, sorry, not equals to, greater than 0, yeah. My x values are greater than 0. My graph for those values will be look like of on the fourth quadrant, because due to these all positive x values, it will be always negative of it, yeah. And when for this kind of thing, when I put my x is less than 0, so it means my a is negative and and I'm entering or applying my negative results values, so it makes positive. So it means my all of negative x values for all of these, let me change the color and I'll keep in red. So for all of my negative x infinity values, my for all of these values, my results will be positive. My results will be positive then, because this will be my y results and my y results will be positive then. So that's how actually we say is that whenever I have these quadrants, so my positive quadrants for the a over x, if it's positive, my graph will be look like this and this. It shows in the first and third quadrant. And when we have minus a of x, it means my a value is negative, then my graph will be more like look this and this for the second quadrant and the fourth quadrant, yeah. So this is a reciprocal graph, and I hope that makes very much clear of you what we had.